I created PostVisit out of actually a clinical need because I wanted to close the loop, not only so that the patient can actually understand every part of the visit, of their medical record, but also so that he could actually get access to the doctor in a more efficient way.
Welcome to the Convergence on ReachMD, where innovators and physicians explore technology transforming medicine. I'm Dr. Brian McDonough, and today we'll be discussing how a practicing cardiologist placed third out of 13,000 people in Anthropic's hackathon. And joining me to talk about what he did and a new tool is Dr. Michal Nedoszytko. He's the founder of PostVisit.ai and an interventional and general cardiologist at Hospitals of Europe in Brussels. Dr. Nedoszytko, it's great to have you here today.
Well, thank you for having me today. It's really an honor.
And it's an honor to have you, and it's really exciting to have you. You placed third in Anthropic's hackathon. As I mentioned before, 13,000 people competed. You're a practicing cardiologist. You were coding in hospital hallways, between patients, on planes, in cloud servers. First of all, how do you pull this off? And when do you even get to the point of saying, I'm going to try to do something like this?
The decision to participate in the hackathon was actually completely random. I've never participated in such a competition. The story behind it is that I had already a trip planned to San Francisco. I was supposed to meet someone who launched a healthcare startup. And a few days before departure, I just saw this ad and I said, why not? I already code for many years. I create software for healthcare. And the idea behind PostVisit was something that was actually behind like 3 years ago. I created a completely different system based on AI, which is called PreVisit.ai. That was an agentic intake system for the patients that gave the doctor a summary. But PostVisit was something that was quite difficult to build in Europe. And I kind of stalled with it. And then when I saw this hackathon ad, I said, why won't I showcase it? But I had no idea how many participants would there be, and I absolutely had no idea of the success and everything that ensued after this.
As we move through our conversation, we're going to talk about what you built and how you looked at the post-visit. I mean, a lot of physicians think about what's happening during the visit, and you were focusing on after the visit as well. And boy, as a family doctor, I know how important that is. But talking about the actual act of doing what you're doing, first of all, for those who understand, we know coding can be very complex, but to do it at the level you do, and it basically was 1 week and you were barely sleeping, paint the picture of what you were trying to do and a sense of what you were doing.
The sleep thing, actually, interventional cardiology and jet lag helped a lot in that way. I am coding all my life throughout my medical career, even before in med school. I've been creating software for whatever, let's say, frustrated me in the medical pathway. But recently, the tools that we have at our disposal just made things so much easier, at least to prototype, that it's even hard to describe. I will, of course, talk you through the whole process, but me personally, I always had this itch to transform whatever I could optimize in my work inside working software. But the hackathon thing and the model that actually Anthropic released, the Opus 4.6, it was just a beast. What this model could achieve in very short time spans was nothing short of remarkable. So I think that, the stars align.
We're going to go through the whole story, but when you're doing this and you're going through it, you probably were just going through the exercise, enjoying the challenge. When did you get to the point, this might actually win?
I had no idea about this until the moment that they have actually announced it. There was this form to apply for the hackathon, and the only thing that it said, just pitch us your idea and you will be among the 500 participants. We had no idea that there were 13,000 applications. I was like 5 days before my departure to San Francisco, and then I got an email in the middle of the night. Oh, you've been qualified to the hackathon and you can start coding in 2 days. And I was just like, oh, okay, I cannot code now because the rules stated clearly, you have exactly 7 days to create a working demo and a film, actually a demo movie. I just started creating it about 24 hours later, the moment that they have announced. They just stated the rules, what you can do, what's the license requirements, repo, it should be public. And what ensued after this was also an incredibly interesting experience because they have created a community of 500 builders that were interacting with each other during this whole hackathon. This was a worldwide online hackathon, so it happened in a virtual community. And people that were just pitching their ideas, helping each other, most of them were actually non-technical. I think that it was like maybe 30%, maybe 40 of people that actually did have engineering background. They have created using Cloud Code the solutions that they had in the back of their heads for a very long time. But my idea, no, I had absolutely no clue. At the end, they have announced 6 people that went into the straight finals, and it was like 20 minutes before announcing the places. And then I placed third, and yeah, I was still in my hotel somewhere in San Francisco. Oh my God, what's happening? And everything that followed after this was nothing short of remarkable.
We were flattered actually, because after you won, I know your LinkedIn dramatically exploded. Real briefly, how do you even think of a way to cut back on all the LinkedIn messages when you're getting so many of them?
Currently, you don't have to know programming in order to create solutions, at least prototypes of solutions or something that you can use personally. Even throughout the process of creating the post visit, I have created like separate tools to help me a little bit. So yeah, the example of LinkedIn is one of them. So the moment that the tweets that was posted by someone went completely viral, I needed to actually turn off all the notifications because my phone just kept vibrating all the time. And I had, I think, like 2,000 invitations on LinkedIn. And I needed to understand who is writing. So I created the scraper. And that took me like 20 minutes using Cloud Code that connected inside the browser, looked throughout my request history, and actually categorized it, showed me how can I actually deal to response. And another cool example was that when I was actually creating the video, because I really thought that the video is only gonna be for 6 judges. It just somebody posted it and it just went completely viral on the internet. I had some like lines that I wanted to say, like for example, this I've done 1,000 procedures in this room. That wasn't actually me. I'm personally quite a humble person, but Cloud Code actually suggested that it would augment your credibility in the face of the judges, that you have some authority and so on. I had those lines that I wanted to speak, but I couldn't remember this. I was like just one afternoon in the cat lab that I could do it. So I created like a teleprompter. It took me like 10 minutes, and Cloud Code basically created an application that worked in the Chrome. It was a teleprompter that I could read out of my laptop. My wife was holding the camera, and I didn't even have the microphone back then. So you can just create tools or even instant applications that can work really well.
It's amazing. I want to go back to your origin, like medical school. Now, listen, when I was in medical school, I thought I was pretty bright and I loved broadcasting. So I would spend evenings at radio and TV stations pouring coffee for people, doing whatever I could to try to get my foot in the door. And I thought that was pretty dramatic. But you weren't just studying, you were building tools way back. You would see a problem and you would come up with an answer, whether it was in finding out about your past, like you were doing virtual exams where you were letting students exchange ideas. I mean, how does your mind work like that? Was it always there naturally?
I think it was always there. I think I started coding around age of 15 or 16, like creating simple websites or whatnot. And when I was actually prepping for med school, I created this sort of preparatory exam, like tests, preparatory tests for med school. And it also went online. Many people were using it. So I always had this parallel thing. Whenever something needed optimization, I created software for this. Like even in med school, for example, that was pre-Facebook era. I was head of Student Scientific Society of Pediatrics. It was really fun time. So I have created like this social website where everybody could post their profile, interact between each other, create scientific projects, and so on. And so there were like many things throughout my medical career. When I was resident, I hated doing paperwork for lab results. So I have created this script that auto-generated PDFs so that you could just put stamp on it with sets of what was necessary. And then everybody started using it. So it grew into the full EHR, so discharge letters. Then we had this problem with duties that were organized just by post-it notes. So I created a module for management of medical duties. Then when I went into interventional cardiology, I created full EHR for creating protocol notes so that it would be just easy. You select the artery, the lesion, the hardware is basically filled in by technicians, and then just select the stent size, pressure. and it creates full protocol notes, which is really necessary also for reporting statistics.
All of us who have lived through the nightmare of the electronic medical record, trying to figure out how to work it, order sets, all those things, we sit around and complain. And maybe we come up with a way to help you get rid of some hard stops or something. But what you are doing is recreating things and using your imagination. The idea of gamification for medical education, making it competitive, and then it works. What about the average physician out there who maybe knows a little bit about technology, wants to do more, and realizes that things are starting to change and they're a little more available than they were? Where do they even begin? Somebody says, I can never do that. What's your advice for them?
I think that every physician has some big idea in the back of his head and wants to create. Most of physicians publish, create papers. I was always publishing less, I was creating more code. And that's true. Before, you needed to go through documentation, learn libraries, some programming language. But since about 3 years, things started to shift. So when AI became mainstream, you could use tools. First, it was Visual Studio Code with some plugins where you could just discuss and it created some code, you could review it. But progressively, it started shifting. You don't even have to actually review the code. You just interact with your program or application, unless you actually have to understand the code. Andrej Karpathy, who was the head of autopilot at Tesla a while back, he's an incredible brain, big influencer on what's happening currently with software. He said that actually the best programming language that you could learn in 2025 is English. And that's absolutely true, with a small caveat. I actually consider that Polish is more efficient, because there was this study by University of Maryland and Microsoft where they have categorized languages in terms of efficiency of interaction with large language models, and Polish actually came out first. Then there was French, and English was actually sixth. Long story short, right now you can just interact with your tools, and the most common tools that you can use, like one thing is called the model, which you could just compare to the level of intelligence that the system expresses. But another thing is the tool. So the way that you actually interact with the model. Cloud Code, actually the hackathon was organized for the first anniversary of Cloud Code. So Cloud Code is a tool made by Anthropic. It was designed by Boris Cherny. So Cloud Code started out as a terminal tool. So if you see geeks and hackers doing something on their computer, they're just typing something in this black screen and the characters appear. So terminal is like a very simple way to interact because it's very fast. You can just type and things will appear. But before, you needed to know like command line interface, you needed to know what commands work. Here you just type code and then you just talk with the terminal and ask them what you want to do. They have launched recently also desktop versions, and if you need a server, you can actually configure a server for you. So everything that was required before going on websites, getting a server or whatnot, it can actually guide you through it, and it can do it much easily. So for me, the terminal was a natural environment where I was always working because it was very efficient. But fret not, you actually do not have to type, because right now, actually, the most efficient way of interacting with LLMs is voice. And it's not actually talking to it and looking the waveform appear, but actually dictating. So I'm using, for example, a tool which is called WhisperFlow. WhisperFlow was very natural because you could talk in many languages at the same time. Like I'm in Belgium, I use Polish, French, Dutch, German, and talk with multiple languages, but it also works very well on your iPhone. So you can like create a virtual keyboard where you have this button that and you dictate. And if somebody types quite fast, he does like 140 words per minute. But if you talk, you generate like 300, 400 words per minute. And what is important for LLM and for your project actually to succeed is really thoroughly explaining what you need. Because the models are really intelligent. They can do very well, but all depends on how this idea will be conveyed to the model and how well will he understand it.
Somebody once told me, if you're going to do anything like this, the train's moving, just get on it. I get the impression you're saying that get the tool and then just start, I guess.
Yeah, the best way of learning is actually by doing so. I mean, the decision to participate in the hackathon, it's not really about talent. It's just the decision to try, because currently AI allows you to prototype much faster. So if you had an idea back at the time, you needed to get the team ready. It took months, it took weeks. And if the idea failed, yeah, you lost a lot of time and resources. Currently, you can just prototype it locally. One thing to mention, and what is important, is also that we still need programmers. We still need software engineers, because there is a big difference between demoing something and actually creating a production-ready software, especially in healthcare, because in healthcare, there's a lot of guardrails. There's privacy, there's data security, there's compliance, there's a lot of legal. So for example, the hackathon demo, it had all the steps necessary to have the HIPAA compliance and so on, but it is not a production-ready program. PreVisit that I built since 3 years, absolutely yes. Although building in Europe is a completely different story. But let's come back a little bit to how somebody that has an idea and no technical background can actually start doing. So you can either just go with Claude Code and tell him, I need this database for patients with chronic heart failure, and I have this subset, and I have access to this kind of data. I can get it out of EHR, but also I have some people working on an Excel file, and you can just put it on your computer and give paths to this file. It will start analyzing it, and you will say, I would like to review the data. I would like to see it, and I don't know, can you make a browser applet that will allow me to interact with it? And you just start going and iterating. And this is a way to go ad hoc and start doing stuff immediately. But if you want to build something that is viable, my process usually is actually to be a product manager. So first you discuss very thoroughly. This is how I did PostVisit. You create this thing which is called PRD, so like product requirement document. And then you ask Claude Code or any other tool to create this document where you want to describe what you actually want. How do you validate that this works? What should be the output? Who are the users? And so on. Just make sure that the model gets you. And the moment that you're at the stage that you think, okay, this is good, you just ask him, all right, so now prepare the plan, how you would implement it. Before, models were struggling with something which was called a context window. So they could just do this kind of chunks of work until they lost their memory, they went out of context, they went out of sync. So you needed to divide this work into certain steps, which is still the case, but the context windows are becoming much bigger, so you can actually delegate a lot more work in one chunk. But what you do is first you create the PRD, so the requirement document, and then you tell him, okay, now give me your proposition, how you would actually implement it, give me a plan. And then he says, okay, I will start with this step where I will give you mockups, where I will create the database, and then you will validate if this is fine. And then you go step by step saying, okay, this is good. So to give you an idea, PostVisit is a quite complicated system. This is really something that requires connecting to electronic health records, wearable data. It needs to interact with the patient. It needs to actually build on top of very technical things that the model provides, sequential thinking, tool use, HIPAA compliance, and so on. So I worked 2 or 3 hours actually discussing with Claude Code, how would I like this system to be created? And then when I created a quite sufficient and long PRD, I said, all right, go to coding. And I thought that it's going to take a day or two. That was my experience before. And 40 minutes later, I come back to the computer and, hey, I'm ready. What? And I check, wow, this is actually quite good. So yeah, of course, there were errors. I still spent a few days after that to polish this, but the speed was nothing short of remarkable. And there was something profound, I think, that happened in engineering somewhere around December 2025, because the models were struggling a little bit. They went out of rails after doing something thoroughly complicated. But I remember I had this break between Christmas and New Year's Eve, and I had this project that I've been doing for a very long time. And I just tried the new model, and it just, in 5 minutes, it's created this functionality, tests, and so on. And I was amazed how fast it went. And I thought maybe that's people just on vacation. They have their time offs, the servers are faster, whatnot. But then people started resonating on the internet that there was something that happened in the models. And it was not only Claude, it was also OpenAI's models that became just so much efficient. So actually, there is some kind of revolution that's happening since about 3 months.
You're listening to The Convergence on ReachMD. I'm Dr. Brian McDonough, and I'm speaking with Dr. Michal Nedoszytko, and we are talking about his work And I'm moving on now to what I think is really exciting. People build AI, and a lot of the AI that's been built helps doctors during visits. But you focused on after the visit. Why is that the gap you chose to address?
Well, it came a little bit from the clinical needs. So you see, 8 years ago, I moved to Belgium. And in Belgium, the system is much more saturated when it comes to pathology, I would say, than in Poland. There's much bigger density of the hospitals. And before, I spent much more time in the cath lab. And here, I started spending much more time in the outpatient clinics. And the first need that I had, and that was actually 3 years ago when the first large language models were released, was that the visit itself might be a little bit inefficient. When you interact with the patient, there's those repetitive questions which come all the time, like what medications are you taking? And patients sometimes they don't remember this. They say like, "Oh, my wife knows this red pill." And this becomes somewhat of a nuisance because within the limited time that you have interacting with your patient, you could make better use of this time. And instead of actually trying to wait until he calls his wife or try to correct the name of the medication that you finally agree upon, you could actually go into the diagnostic part and make better use of your neural network. I tried to experiment with large language models, and I have created PreVisit.ai, so the system that talks with the patient before the visit and in a very polite and empathetic way asks all the pertinent questions. I started out with cardiology, first visit, comorbidities, medication, risk factors, so on. And then it provides you with medical grade summary, but the summary shouldn't replace the anamnesis. It just gives you like the script that you could interact with the patient. You can use some parts of it into the EHR, but the goal is actually to increase the quality of your interaction with the patient. And what I have observed actually is it was not only the real time gain and difference, but the quality has improved tremendously because the patients talk at home where they know what they take, they have support of their family, and moreover, they are better prepared to what will happen during the visit. We are already like getting straight to the point, and the visit is just become so much more efficient. That was the idea, and I actually created PreVisit 3 years ago. We have integrated it with many systems in Poland and Belgium and Greece. It works really well. We already have 100,000 PreVisits that are working. The only caveat was actually that you need to tap directly into the workflow. So like you cannot provide an accessory, a secondary tool that, although there is a big gain in efficiency, but not many people grasp that immediately. We needed to tap that immediately to like online agendas, electronic health records, so that it's like directly integrated. But coming back to post-visit, another problem is that when the patients leave the doctor's office, they usually forget a lot of information, like what this Mediterranean diet, why did he actually give me this medication? What are the possible statin adverse effects? What does it mean muscle pain? Where? And when should I come back? What lab works? When should I do the CT scan? Should I be fasting? And so on. And the patients sometimes try to call you. Sometimes a lot of patients try to call you and you like stack up with all this demand. And I wanted to create this tool a long time ago, but the problem is that in Europe, unfortunately, creating any sort of solution that implies diagnostic part of AI is incredibly overburdened with red tape. And so I concentrated more on PreVisit, the administrative tool. And here I thought that when I'm going to US, where there is a completely other principle, where you have actually a big boost and there's not much red tape. And yes, of course, there's HIPAA, there's PHI, GDPR also works here, but people start actually creating. The amount of startups that are blossoming currently around healthcare in the last month is just short of astounding. I created post-visit out of actually a clinical need because I wanted to close the loop, not only so that the patient can actually understand every part of the visit of their medical record, but also so that he could actually get access to the doctor in a more efficient way, because like you have adverse effects after propranolol and you want to know if it is actually propranolol or maybe you should reduce the dose or whatnot. So you can actually ask this question. It goes back to the doctor, and there's another LLM that will help the doctor actually analyze whether the patient needs to go back, whether the patient can just have his dose reduced, or you can just reassure him. And this kind of makes this part post-visit much more efficient.
As a family doc, I can see where your motivation was because, especially with, for instance, heart failure, when people go home, things can really fall apart. They get confused about their medication. Maybe they're gaining weight, and next time you see them, they're back in the emergency room or they're admitted to the hospital. So I think what you're trying to do is get past that. Walk me through it. You have PostVisit.ai, so you've developed this tool. Does the patient have a microphone they're talking into? Are they on their computer? How do they get the information to you essentially through the tool?
Yeah, so basically, I needed to find a way how you can get the most accessible data inside the context. And on one hand, you can try to access the EHR, which is incredibly fragmented. And in most cases, actually, it's virtually impossible to access it. But if the patient actually has its own tool, then he can collect the data. So one way is reverse AI scribe. Long story short, AI scribes are systems that listen to the discussion between the doctor and the patient, and then they create protocol notes. So these are mostly doctor-facing applications. And I thought, why not create a tool like this for the patient, where the output of the transcript is actually more centered around patient needs. And of course, it needs consent. So I thought all the information that you get during the discussion with the doctor, you will have it. You won't lose a word, and you will have one thing that is relevant to the context. By context, the things that the data that you put inside the model. And then you can access also the data that the patient has at his disposal, like wearable data, like Apple Health data, if possible. You can upload lab works. You can upload any kind of other documentation that you have in paper or PDF format. And because medicine is science which is based on evidence, the most important part of it is actually putting in the clinical reference, because we won't let the model actually do the clinical judgment if it won't be based on actual medical data. So I wanted also to give this part where you can actually upload guidelines or connect to existing services that can provide real clinical guidelines and reference. And based on this, you could get the output that the patient needs.
You're really empowering patients to be better partners with you. I mean, this is really giving them a chance to team up with you. That kind of changes your role as well, too. It expands it, doesn't it?
Previously, you had patients that came with Dr. Google diagnosis. I personally adore the patients that come with Dr. ChatGPT. I have a lot to talk about with them, and they are so well prepared. And for me, giving the patient a tool that will let him understand the health is actually going to improve you as a doctor as well, because you will just become a better specialist treating the patients, not going through the noise of the data that is irrelevant and trying to steer the patient towards the better way. You are actually a clinician at that time. You're treating the disease, which is easier, identified more easily. So I personally believe that healthcare should be optimized in that way, that we should try to reduce the noise that surrounds the diagnostic and also the treatment part by enabling both the patient and the doctor. It should go both ways.
And big picture, as you're already seeing it, and I know you've thought this through, and you think it'll make your job ultimately easier or harder? I think I know the answer, but I want to ask you.
I think it will make it absolutely easier. It depends on what you like to do. But for me, I absolutely love treating, identifying. We doctors, we are special kinds of neural networks. We train all our life to identify the patterns around our patients and categorize them into clinical categories, diseases, and then we just use the tools that we have at our disposal. And if we eliminate the administrative burden, the noise part, this will allow us to better serve what we are trained for.
How will this change your practice if all your patients were using this in your cardiology practice? You think your success rate and your metrics and everything would be better? You think they'd be healthier? What are your thoughts?
Well, let's say two elements. The first is the part that I think is the most relevant nowadays, and this is the administrative workload. Because if you see currently the things that the elements that we complain the most as doctors in advanced countries is basically the administrative workload and the burden that it encumbers, and the rate of burnout that actually ensues after this. this will help tremendously when it comes to focusing more on the clinical part and I would say bring back joy to medicine. And the second part is basically the efficiency and how healthcare can actually improve in terms of outcomes. So first thing, imagine that, I don't know, why actually the hospitalizations take so long. It's not because we don't have the capacity to treat the patient, but sometimes going through all the data, identifying it just takes so long. The doctors don't have the bandwidth. So you could dramatically reduce the hospitalization duration and also reduce the hospitalization rates. Let's take the example of chronic heart failure, right? We all know that in order to reduce the early hospitalization, you need to follow the patient's weight. You need to detect the signals that will tell that the patient will soon crash and will require hospitalization, which will mostly take a long time. So this kind of patient empowerment will also allow this loop to close. We have a lot of problems in post-coronary treatment. There's a low adherence to antiplatelet medication, and the amount of thrombosis that we get on the 7th day after discharge is it's not really that high in Belgium, but it is a significant problem. And it can help with the compliance because if you have a tool which is friendly, which is easy to access, and which presents the patient with the data in the most digestive way, I could say, can tremendously help also with all that we struggle with in maintaining compliance and maintaining the readmission rate and maintaining basically adherence of the patient to the whole follow-up.
With innovation, there's a great deal of responsibility as well. And ticking off some things from a list, you build something fast and you're able to do that, but how do you factor in patient safety, or a patient misinterprets something in post-visit AI and all of a sudden when they misinterpret it, they make a harmful decision? How do you guard against those things?
So one very important thing is that current large language models are mostly probabilistic. And as high as this probability could be, we need to make sure that in medicine, we still adhere to the same principles that we were adhering for ages, which is deterministic, which is predictable outcomes. So that's why an essential element is the doctor in the loop that always validates and takes responsibility. The pace of innovation in engineering and software is absolutely blazing. It's incredible how fast those tools evolve. And medicine, unfortunately, will struggle a little bit to catch up with this, which I don't necessarily think is a bad thing. We still need to validate clinical trials. We still need to adhere to evidence-based principles. In engineering and software, you can validate if a solution works by doing something which is called testing, unit testing. And if it will fail, it fails. And then we just create other code, which is not the case in medicine, because here we deal with human life, because we deal with quality of life. There are guardrails, there are principles, and what we need to do is basically try to convert our clinical practice, clinical principles, and workflows inside something that will be predictable and inside something that will actually be useful. So in Europe, it's quite difficult because medicine and all the healthcare applications regarding AI, they are currently classified as the highest risk. And if you actually want to create a similar solution, then you need to go through the whole process of screening, audits, ability, which is an incredibly difficult thing in AI models. But you need to also adhere to the principles of patient safety, of traceability, of how you actually share the data, who can share what kind of data, like the patient needs to give consent to certain elements, the doctor needs to give consent to certain elements. So healthcare is much more complicated than this, and demoing something or creating a small tool is incredibly rewarding, and it can actually push discovery further. But in order to create something that works on a large scale, on a population scale, and actually takes clinical decisions, helps the doctor with the clinical decisions, is a completely different story. And it needs to be created by people that know what they're doing, that have the clinical experience, that are responsible for creating clinical solutions already, I think AI will accelerate that. Like clinical trials can be actually created with better scope and better efficiency. Like we have already tried to using PreVisit.ai and selecting patients for clinical trials. And actually the groups of patients that you get are much better than if you would do like manual. Of course, you always do manual screening after this, but you can just create that. In rare diseases, I think that's a very modern solution. And in the hackathon itself, among 500 people that were the builders, at least 3 solutions were actually concentrating around rare diseases. And some of those were actually about generative data, and some of those were actually about looking for patients with rare diseases. For example, there was even an interventional cardiologist from Japan that created this taxonomy system for better explainability of medical coding in Japan.
I'm interested in a couple things you're doing, and it really plays out because as a physician, you were the lone coder working on the plane at 30,000 feet, and you were alone doing things between patients, but also you've recognized the importance of medical teamwork because whatever you develop has to be studied for best medicine. It has to be team based, and you have to collaborate. And when you talk about collaboration and coding and building and doing these things, are we failing our medical students or our residents? Should we be teaching them about building and coding, encouraging them? Because one thing's clear to me, the insight you have as a practicing physician is helping guide your decisions in what you're going to do with AI and building. Are we failing them by not getting some of these medical minds more involved at an early stage?
I wouldn't go so far as to call it failing, but AI is the current outlet to creativity. It is absolutely necessary to give students, future doctors, the tools and understanding how they could use them to better shape their work. Currently, as Boris Cherny, the creator of Cloud Code, said, programming is mostly solved. What is not solved is scaling the software on the production levels. But if you have an idea, you can just create the working solution for that and do it as fast as possible. If I recall the problems that I had during my medical studies and so on, I would create so much more. It took sometimes really a long time. The electronic health record for interventional cardiology took me like 3 years actually to code during the nights, during the shifts. And now I think it would take a few weeks and maybe somebody that could help me with scaling into the production levels and secure it. But I think that it's absolutely compulsory to add programming. Well, not programming. I wouldn't even call it programming, like AI coding, AI generation, AI creativity inside the curriculum. There is this term which is called vibe coding that was actually pitched by Andrej Karpathy, which at the beginning was, well, quite, let's say, trendy. But I don't really like this term because vibe coding means that you just absolutely don't look at, let's say, the technical part of you have created, how it works under the hood and so on. And while it's really cool and groovy to just vibe and talk to your AI and create some nice program that will work, in healthcare, you need to understand the process. And that's why I said that it's quite important to first lay down a document with the requirements, both on the user interface, both on the backend, so the things that interact with your database and servers, and both on the security part, because this is something that you will have to validate every step of the way. So small things, yes, but if you build bigger projects that actually deal with safe data, with a lot of data that work in clinical settings, that then this is also a part that needs to be done. I talk a lot about AI since about 3 or 4 years. I am present at many congresses and scientific meetings, and I talk about how AI is reshaping the world. And I think that it's only the last year that people started actually to grasp the potential of it. And currently the potential they realize in more, I would say, general way. So you have your chat GPT on your phone, you can discuss with it, and the outputs that it produces are just wow, because you can discuss your taxes, you can discuss your current problems. But the real deal actually is like to go into this creative part and start like transferring your domain expertise, which was actually the theme of the hackathon. Start transferring your domain expertise into some kind of a working solution.
How we have a lot of physicians who listen to this, and I know they're probably going, want more of this, doctor. I want to hear more. This isn't enough time. Where can physicians follow you, reach you? Is there a way they can learn more about what you're doing and kind of learn more from what you are doing?
Yes, certainly. My LinkedIn currently went into normal mode, so I can respond freely. I'm also on Twitter. If you want to reach out, don't hesitate. I will be very happy. I think that I will be in the US more often right now because I quickly realized how big the opportunity is. And I was just astounded by the speed and the creativity of the community in here. I came here 3 weeks ago. I was supposed to stay 2 weeks. Right now, I needed to extend my stay, and I didn't know anyone. And right now, I just interact with the sharpest and brightest of Stanford. It's incredible how fast you can just meet people, validate your idea. And this is the center of the universe when it comes to AI development.
We'll be lucky to have you. I mean, you're talking about being with the best and the brightest. You're very bright yourself, and yet you're humble. And I think that is one of the attractions, that you're open to talk to people, and you're showing physicians they don't have to wait for IT departments, vendors, all those things, that they can do things themselves. And I think that's a very powerful message. And I want to thank you for spending the last hour with us. I really appreciate the time, and I know how you are in demand. And I thank you for sharing your journey, where it's going. And obviously, we're all going to be following you and hopefully connecting here and there in the future as well.
Thank you so very much for having me.
You've been listening to The Convergence on ReachMD, where innovators and physicians explore the technology transforming medicine. To hear about other technological advances shaping the future of healthcare, visit The Convergence on ReachMD.com, where you can be part of the knowledge. Thanks for listening. We'll see you next time.